We are looking at a 5,000 share order.
Welcome back to Google Cloud Live, everyone. I am Priya, a Developer Relations Engineering Manager at Google Cloud. In today's session, we are diving deep into the world of AI agents, and we will be building a fully distributed multi-agent system deploying in Google Cloud on Cloud Run. And I'm thrilled to have Sheer joining me to make it happen.
Hi everyone, I'm Sheila. I'm a developer relations engineering manager here at Google Cloud, and I'm extremely excited to be here today with you, Priya, and all of our wonderful audience. Also wanted to thank our team member, the Google Cloud experts, Janet Wong, Bob Furu, and Balaji Subramaniam, who would be helping us today with answering your questions and comment in the chat in the comments to the different threads. So keep them coming, please. We want to hear from you.
Yeah, we do. And if you tuned into our last episode, you saw we were broadcasting live from the Shoreline Amphitheater for Google I/O, where we chatted through all the exciting announcements around Firebase, Flutter, and AI. We talked with startup founders about how they're utilizing Gemini and had some great conversations with our Google developer experts. If you missed it, check the YouTube description to catch that. But this week, we are focusing on something incredibly hands on. By the end of this episode, you are all equipped to build a multi agent system and deploy it to Cloud Run. Sheer, do you want to share your screen and walk through what we will be building today?
Definitely, definitely. So let's pull the slides. Okay, I hope everyone can see my screen. Before we dive into the code here, we want to hear a little bit from our audience. Let's test our chat or comments features. Please share with us. Have you ever tried to build an agent? And if you build an agent, did it make it through all the way to production? Is it actually serving you or your users? And what are the things that stop your agent from making it to production? So please share it with us, and I will also try to connect to the chat and follow. Okay, let's see if I can connect to the chat and see you all. Is there any chat here? I see a lot of people are saying hi. We want to hear from you. Yes, production. So, did you try to build an agent, and what prevented you from bringing it to production? I want to hear. So, I can share with you that last month I had a talk at Google Cloud Next, and I asked the same question to a lot of people, and many people told me, yeah, but how do I know my agent is really working when it's live in production, or it's really delivering value and doing what I'm expected? So that was one issue that we encountered. We also heard about issues with securing the agent. How do I make sure my agent is actually not being maliciously abused? How about you, Priya? How many agents did you build that still live on your local machine and never made it to production?
I think there's a lot of them. I presented at Next as well last month, and like I had same questions. I used the Cloud Run MCP server though to deploy my agents, and kind of like integrated some of the security capabilities along with like identity and access management, content safety, which comes as a part of the managed MCP server. But I still have a bunch of those somewhere sitting on my laptop which I haven't like pushed to the production. So I think moving from a cool local script to a resilient production ready system is I feel it's a massive leap. What do you think, Sheer?
Yeah, exactly. It's one thing to have like a fun little local experiments, but making it robust enough to handle real world traffic is completely different thing. That's why we built this series of 3 labs called the Production Ready AI. And you can see here the links to those 3 labs that we have here. Today, we're going to cover the first lab, the Build a Multi Agent System one, but it will not be ready for production traffic yet. In the next session in June 30, we will cover evaluation of our agent to make sure they're actually bringing value. And on July 28th, we will cover a very important topic, how to secure our agents to make sure they cannot be manipulated by malicious actors. So today we're going to start with lab 1, and you can feel free to go through the next labs if you'd like. Even before our next session, they are all available to you online. So you can see we have barcodes, we have the links here. It should be very simple.
Uh, I think before we build our multi-agent system today, let's ground ourselves here. What exactly is an agent from your point of view?
So an AI agent is a system that uses a model to reason about and select the appropriate tools to achieve a specific goal. It can independently make decisions and take actions.
I think that's spot on. And I would say to put that into practice today, we are building an application called the AI Course Creator, which turns any topic into a complete course. And I feel it's time appropriate as well, as a lot of us are like kind of learning new things with like new terms and technologies coming every day with AI. We are trying to be up to date. And I think one of the things that I would want to like ensure when I'm learning is that all of these courses that I'm taking is factually correct and I'm taking the right source of information for me to like move ahead. And that's exactly what we're building today. It's like a team of AI agents that will research, fact check, and write a comprehensive course for you just in seconds.
Yeah, yeah, this is definitely the era of learning and the era of building. So, this is the architecture we are building today for the course creation system. So, notice the modularity. Instead of just one monolithic prompt that does everything for us, including, the research, the drafting, the judging, actually building the course, we have a squad of specialists, each focused on a specific task, coordinated by one orchestrator. This design is very helpful for production because small focused agents are easier to evaluate, debug, and scale independently.
And that's great. And we have the power squad right now. But what are the three key technologies that we are using today?
So, to move from a conceptual multi agent design to the production ready reality, we rely on this very specific stack that is designed for scale, for modularity, and enterprise reliability. First, we are using the Google Agent Development Kit, or ADK. It's a framework that simplifies building and running AI agents. Next, we have A2A. That is an open communication protocol that enables the different AI agents built on various frameworks and platforms to discover each other capabilities and securely collaborate on complex tasks, which you will see that today because we have, as we mentioned, a distributed system of multiple agents. Um, and finally, Google Cloud Run, our serverless platform for running containers at scale. This is where our agents will live. Each of our AI agents will run on its own Cloud Run container. And if you like to learn more about any of these technologies and frameworks, we really recommend checking out the Agent Factory, our video podcast that dives into these topics. Just search YouTube for the Agent Factory or find us in the podcast area of Google Cloud Tech YouTube channel. And we also have all the links to everything we discussed here in the description for this live stream.
I feel like Agent Factory is amazing. I've been like watching those episodes. They're like been such cool discussions around memory, eval, security, and the recent one was also the Gemma 4 launch that we had. So do watch those, and that will help you dive deeper into the world of AI agents as well. So moving on, let's see what we are going to build in action. Uh, can you play that for me, Sheer? Yeah.
Yes, it is running.
So you see, we give a very simple prompt to our researcher agent, and it does the research, and the judge will evaluate it, and then the content builder, it's running, the content builder is going to build the course for us, and you see how well structured it is with different modules. And I kind of mentioned the squad with the little demo, but let's break down the squad. Who is up first here?
So our first production microservice or agent is the researcher. Its singular role in the world is information retrieval. It utilizes the web search tool to fetch current relevant data, ensuring the information is grounded in recent knowledge.
I think I will never use my first draft of blog that I create, and I always prefer to reiterate on or iterate on that. So I don't think we can just trust the first draft that the researcher gives us, right?
This is one of the coolest things about this lab, to my opinion. The judge pattern. Adding a judge agent to your production architecture is a wonderful way to ensure quality at scale without manually reviewing every model output, right? Audience chat, chime in the chat if you hate to review an LLM output and look for hallucinations. So, this is what the judge basically can do for you. The judge agent provides a programmatic quality gate. It returns a structured output with a predictable JSON response that provides a or fail plus the detailed feedbacks of what went wrong. According to the judge output, the code would take a deterministic action, either call the researcher to further research or break the loop to move to the next stage to build the course around the approved research.
So I guess it's like an LLM grader. I know we're going to talk more about it in the next lab, that is the eval lab that happens next month. But I think, for example, in this case, an answer this short, like linear algebra is a branch of mathematics, would not pass the judge. I feel like it'll ask for more detail as worthy of a full blown linear algebra course. So this would go back to the researcher for another pass for more detailed research.
So let's see how ADK allows us to give the ability for the judge to accept or reject research findings. The ADK, what's really cool about it has this built-in playground to test our agents. It's called the ADK Web UI. It allows us to test individual components in isolation, ensuring that the judge logic or the researcher tool usage is perfected before it enters the broader orchestration. So let's see, this is the ADK Web UI, and now we are talking only with the judge, okay? So we're asking it, hi, who are you? And you can see it fails because this is, not an approved research output. And you can see the feedback is provided in the feedback. And then we give it an output of a research on linear algebra. Linear algebra is a branch of mathematics. And you can see it will fail because this is not enough detailed for a full-blown linear algebra course. So you can see how the judge always returned a structure output to the prompts. When given the linear algebra, it fails, as Priya mentioned.
And I feel this is great for debugging. I can feed the judge some terrible research I just made up and verify if it fails me with structured JSON. So it's much easier to debug this now when it's before. Otherwise, like if it's buried under a massive workflow, it'll be like you're kind of running into loop and trying to fix and troubleshoot. But how would the researcher and judge interact? Are we using some pattern here?
Yes, so we will use the LoopAgent architecture supported within ADK to have the researcher and the judge work with each other. It automates that iterative feedback cycle between them until a specific exit condition is met, meaning that the quality standards are approved. We also set a maximum iteration limit so our agents don't get stuck in an endless loop if a topic is too broad.
I think getting in this endless loop would be the worst thing to happen. You're like running and running and using up all your tokens, and it's
Yes.
great to have that limit set. But what happens once the judge finally approves the research?
Then we hand it off to the content builder or writer. It takes the validated research findings and transform them into a polished, structured final product. Because the research already has been judged, the writer can focus exclusively on the formatting and flow. And we share this lab with you so you can also take it and make it better. You can incorporate image generation, you can add quizzes, all kinds of different tools to the content builder, which is what is so amazing about this modularity. You can adapt each of the components according to your requirements.
And so, as you mentioned, the writer basically focuses exclusively on the formatting and flow, and that's where I think the sequential agent architecture, which is also supported by ADK, comes into play. To build an entire flow of our agents' collaborations. Once the researchers approved by the judge, which runs in a loop, as Shir mentioned, the sequential patterns allows our data to flow sequentially through the pipeline, passing directly to the writer to be formatted.
Yes, and we mentioned that all of these agents are independent services, each deployed on their own Cloud Run endpoint. Our audience is probably wondering, Priya, how do they communicate with each other?
That's true. We're deploying these agents as independent services to Cloud Run so that we ensure that they can scale based on demand and fail gracefully without impacting the rest of the orchestrated pipeline. But to answer your other question, here on how these agents communicate with each other. So we are using agent to agent protocol, that is A2A, which Shir just highlighted earlier in the slides when we were talking about the three key technologies, that it's an open standard that is designed to be the common language for agent to communicate and collaborate regardless of how each of these agent is implemented. And if you see here, every service publishes an agent card. What is it? It's just a JSON file hosted at a well-known URL. And this is more, if you think of it in simple terms, it's more like a business card, which tells the other A2A agent what the agent is, what it can do, and how to connect with it. So now our agents can speak with each other regardless of the language, deployment framework, or scale. The writer agent connected to the researcher agent via just simple HTTP line, not a hard coded link. So this allows the agent to discover and communicate with each other over standard HTTP, making the system framework agnostic and truly distributed. And even if our writer agent to discover, and even if our outer agent needs to scale up or be swapped out entirely, our agents continue to act as microservices whose communication is facilitated through this A2A.
Definitely. And I think it's really cool that, the fact that each agent is independent, it could also allow different teams to build the different agents and even build them in different languages. Like you can see here, you have one speaking all saying hola, one saying bonjour, and they can still communicate because they all this is just an analogy, but they can all talk because they're speaking A2A language. So multi-agent system brings a lot of benefit in terms of independent scaling and having a more focused agents with clear roles and small number of tools, which in many cases makes them more accurate and successful in their tasks. It avoids that tool bloat phenomenon when agents just get confused because it has too many tools and too many tasks. But we also need to take under account that in a distributed system like this, we need to explicitly manage the state, the context, and the source of truth between all of these agents. How do we do that, Priya?
That's a great question, Shir. And we do that with the orchestrator. So we have the orchestrator that manages the global session state, acting as the source of truth that ensures context is propagated correctly from one specialist to the next, that is, one agent to the other, as the task progresses.
And this is how our architecture would look like all put together. The front end connect to just one port, but it gets live updates from the whole squad. So you see it connects here in the orchestrator. This is the user experience we want. So let's start building it. Please copy the link to the lab. It's good.gil/PRAI dash rs dash one, and you also have it in the description for this event, and maybe someone can also add that to the chat. And by the way, I already noticed in the chat that someone wrote that they wrote a judge pattern for their image generation and their generative models, so well done, and keep on sharing your great experiments. Priya, do you want to take over the screen and walk through the lab with us?
Yeah, let's go. Bringing up my Cloud Shell now. And while that comes up, we will be going through this code lab, the code lab that Shir just shared, the link to that code lab. And you can try it along with us using your existing project, or if you do not have an existing project that you can also use the cloud free trial option, which gives you access to free tier products for 90 days. With a $300 credit, and the link to that is in the description, and the TAs can also help share those links. But if you see, when you start a new project, or when you create a log into console.googlecloud.com, this is the first page that you would see, which gives you an option to try the $300 free credit. So that's the option that you can use. And again, you don't have to run through the lab simultaneously with us. We're just doing a walkthrough, and you can do it now if you have a project, or you can do it later whenever you have time. So, all right, let's go to the Cloud Shell now. So how do I go to my Cloud Shell? So the first thing is I am in my console, and what I do is click on the top right corner on the terminal symbol, which says activate Cloud Shell. So I will click on that. It's the top right corner.
And Priya, the Cloud Shell is free with a GCP account, right?
It is. It's free with limits, more than enough for this lab. So let's click on the terminal on the top right corner. It opens up the Cloud Shell and the Cloud Editor. So I did have Cloud Editor open before, but there's an option that pops up at the top, which you can choose to open the Cloud Editor. So next, what I'll be doing is opening the terminal. Click on Terminal, New Terminal. So if you see, this opens up a terminal at the bottom for me. Now, I'm using a project which has billing enabled, but as I mentioned, like the TAs will be sharing the link of the steps. But before I move on, I just want to ensure I'm just showing you how to create a new project. I'll not be attaching the billing to that, but just running the command. So you can use a G Cloud. Sorry, give me 1 second. G-Cloud projects create, and you can give a name, say multi-agent test lab 1. So once you run the command, what it'll automatically do is it'll create the project for you. But after the project is created, you need to link it to a billing account. I'm not showing that through here, but what we'll do is we'll add a link to a lab specifically that shows how you can link a project to a billing account in case you haven't done it before. Yeah. But moving on, for today, I will be using existing project that I've created, which is linked to a billing account, which is the Production Ready AI Lab 1. And let's ensure the first step I want to do is that my Cloud Shell is using the right project. So what I'm going to do is just gcloud config set project command with project ID. And how do you find your project ID? So you will click at the top here, and here you would see the project name, and this is the project ID. So just copy this project ID from here, and I would just paste it here and run it. So what it would do is it will ensure that the Cloud Shell terminal that I'm using is authenticated and it's using the right project, and it's not basically creating and spinning up resources in some other random project. Now that we have the project set, let's clone the starter repo. So we go back to the code lab, and this is the introduction. We just talked about all of this in the architecture discussion. So we move on to the setup. So we go to the starter code. So for this, I'm just going to copy this, cloning the repository. So let's clone the starter pack and just paste it here.
That is a really long Git command, but all that it does is to get us to the specific project we need out of the repo with the starter code, which is just the scaffolding of our multi-agent system, right, Priya? So can you show us what does the project look like now after you
Yeah, I
git?
think so. I'm just going to ls it. So ls, it has multiple uh, file options, and then I'll just go to the agents file to show the different uh, agents that we have here. So if you see, we have the content builder, the judge, the orchestrator, and the researcher.
So you can see each agent has its own folder. That is telling me they're meant to be independent, right?
Yes, they are. So completely, you can have different teams owning different agent folders, different deployment schedules, and different scaling configs. So they're basically like microservices.
Which is either exciting or terrifying, depending on how you feel about microservices, right?
I think that that's both valid, but yeah, let's go ahead to the next step, and we will enable the APIs. So every services by default in so every service in Google Cloud has an API attached to it. So it ensures when you haven't enabled those services and you're not using those services, it's not like adding to your bill. So what it would do is you would need to enable the APIs for you to be able to use those services. So let's copy this, and let me just do is the clear the screen so that it helps people see what I'm running. And then I just paste it here and enter.
Okay, so while this is running, first of all, I wanted to mention that the top most reason of failure in this part is if you did not set up the project ID correctly. So Priya, this is a test for you to see if you correctly set the project ID. So that's one. And I also wanted to ask you a question, Priya. Is this a lot of APIs for just this simple lab?
I think first of all, I did set the project ID correctly, but let's wait and
I
watch.
don't know. Let's see.
um, I, to your other questions around a lot of APIs, I don't think it's a lot. Because we're deploying our agents to Cloud Run. So we definitely need the run googleapis.com. That's for Cloud Run. And then the artifact registry stores the container images that we have. The cloud build googleapis.com. That one is basically used for the cloud build. And then the AI platform is for the Gemini enterprise agent platform for our Gemini endpoint. And compute is a dependency from a networking standpoint, so that's why we have it. And I feel like every project, most of the project, these are like the standard ones. So if you're using Cloud Run, and if you're calling your Gemini API endpoint, so you would have these as the basic APIs running. Yeah.
Awesome. So I see you actually said the project correctly. Well done, Priya. And I'm glad to hear from you that we're not adding any overhead. All the APIs here are exactly what we need for this lab.
Yes, we do. So now let's go and run and install the dependencies. I don't think I have UV installed for me before. So first I'm going to run pip install UV because this is a new Cloud Shell instance, and then I will do a UV sync.
Okay, let's talk about UV. We've been using it a lot in our Google Cloud Labs recently. And audience, if you have any thoughts about UV versus PEEP, please let us know. Or if you haven't heard about UV, also share with us in the chat. Priya, can you share with our audience why do we like UV so much?
I think it's think of it as PIP, but I feel like written in Rust because it's extremely fast. It also handles virtual environments and project scripts all in one tool. So, and I've switched to it, and I generally just can't go back to anything else now.
Yes, yes. I just love how fast it is. Once you go UV, you can never go back, right? Yes.
Ta-da. Okay. Okay, so I think I'm in the wrong folder. Let's see. No, I do have pyproject.toml. Not sure why is it not syncing.
Can you go to the right folder, maybe?
I am in the right folder. Okay, I think, yeah, sorry, I'm not. Yes, because I cleared the screen. So, yes.
These are the best learning moments. So notice this: when we are failing, you are learning.
Yeah,
Great.
I did CD agents and I was like, maybe I'm going to the right folder, but I was not in the right parent folder already. So
We
I was just shooting in the air.
were just blabbering about UV and this. Yeah. Okay, now it's working.
Yeah, see how fast it is. It's like getting all the dependencies like super quick.
Yeah, and I see people are also cheering in the chat. UV rocks.
Yeah,
Yeah.
it does. So now what do we have? The next step is environment variables. Yeah. So now, and this is, I think, one of the most critical things that I've seen. And like all of these road shows and labs that we've been running, I would want to ensure that we just like get these environment variable rights and source these environment variables.
Yeah, so when we are running these labs in events, one of the most common issues we encounter with attendees is that they forget to resource the .env file when opening a new terminal tab. Does it happen to you too, Priya?
It doesn't. I've done it multiple times, and you might see me doing that again today, like when I run multiple like parallel instance of the terminal to deploy our agents to Cloud Run. You never know, I might just miss it.
Yes, yes. And hey, our TAs, can you help with writing it in the chat right now so everyone won't forget source.env in every new tab?
I think we should make a t-shirt of that. What do you think, Shir?
I would wear that t-shirt.
Okay, so this is done. Now let's move on to the next step in the lab. Now, the next step that you see is the researcher agent. And I would open that, but this step that we have here, because we have the Cloud Shell workspace already open, so I'm not going to run this because I don't want to like create another like virtual instance. So I'm just going to use the existing instance that I have. Then let's go to our editor and then go to agents, and then agents, as we discussed, we have all of these agents folder because it's a starter pack, so you already have the initial agent folder ready. So we go to researcher and then open the agents.python file. That is agents.py, agent.py, not agents. to be
So this
specific.
is just a starter code for the agent. And now we need to actually paste the actual code, right? I'm really curious how long this file would be. It can't be too long if it just, go search the web, right?
Yeah, I think it's not. So if you see here, like if we go back to the code lab here, we just have like small agent definition. And I'm just going to copy this agent definition and paste it back to the to do section. So we do have a to do section in our agent.py file, that is agent.python file. And I'm just going to add it. So just leave it there for people to see it so that I'm not like overriding on top of that. But here, if you see it, it says defining the research or define the researcher agents. And like you have all of these existing imports here. So all we need to do is just copy and paste the agent definition for the researcher here.
Awesome. So I think you can definitely delete that to do if you're good with that.
Yeah,
Uh,
I'm good with that. I just left it just in case if
yeah.
people want to just see it.
Just
Yeah.
yeah, just so we won't get confused
Yeah.
about this. Yeah, so I think it's very cool. It's pretty short. We don't have any APIs key provided, no, get request, nothing, right?
Exactly, because we're using Gemini 3. The Google search tool is automatically available by default with that. Yeah.
Oh, that's great. So what if we would use an older model like Gemini 2.5?
I think if you're using an older model like Gemini 2.5, you would just need to pass, if you see here in the code lab, that is tools is equal to Google search as an additional parameter to the agent constructor.
I see. Okay, but how does the model actually communicate with this tool?
So the ADK handles the complexity of describing this tool to the LLM. When the model decides it needs more information, it generates a structured tool call. Then the ADK automatically executes that Python function, which is the Google search, behind the scenes and feeds the result back to the model. So you don't write any of the boilerplate code here. So you just like kind of skip that.
Come on, that just feels like cheating to me.
I think that's a good cheating. I mean, this is the extraction working correctly, and you would want to focus on what the agent is doing instead of the plumbing and not like have to write all of these additional code, which is kind of like available. And, the ADK kind of like is able to manage and handle that.
But there's something interesting in the instruction here. In the last line, it says, "Do not output any function calls." Why do you have to say that explicitly?
I think that's a really good catch. I didn't see it as either, but I feel like sometimes the model will output the raw tool call syntax. So, like the JSON blob, it was going to send instead of giving you a summarized answer, and this instruction prevents that. So, what it does, the next agent in the pipeline needs just something which is more readable and easier to consume, not a function invocation object.
I see. I see. So that's basically prompt engineering, but at the agent level.
Exactly, and it's shaping the behavior through instruction, just like you would tune a regular prompt. It's just doing that for the agent here.
Okay, and can I ask what our model is set to? I see it's like a constant variable model.
Yeah, let's check. Yeah, it's here. It's here, right here. So we have it. Let me show that. It's just defined at the top here, and it is the Gemini 3 Flash preview by default, which is fast and capable enough for the research and iteration that we're doing with the distributed multi-agent system.
Definitely capable, but we wanted to note here that Gemini 3.5 was just launched last week. And if you haven't already, you should definitely go ahead and try that. Do you know that model is up to 4 times faster than any other frontier models? I was just blown away when I heard that. How many of you already tried Gemini 3.5? How did you find it? Please share it with us in the chat. And Priya, one of the things I hate most about working with agents is the need to review their outputs. And if you also hate reviewing agent outputs, please chime in the chat about that. So we discussed that before when we showed our architecture in the beginning, that we will use another agent to do the reviews for us, right, Priya?
Yes, that's correct. And if we go back to the code lab and we move to the next step, that is the step 5, that's the judge agent. So here you are, meet the judge, and this one has personality share.
Yes, when I hear judge, I'm already nervous.
Who is not? I think all of us are nervous when we hear about the judge. But let's go ahead and open the agent.py or the agent.python file for the judge. So we go back to the console, and here again, going back to the agents on the left hand side, we have all of these. Where you go? So we have the judge here. You click on the judge and you have an agent. I'll close the other one just to avoid confusion, which is for the researcher, and open the judge agent.python file. Yeah. And two things make this agent special. We will see that in the lab. So the first one is defining the schema, that is basically the structured output of what the judge agent is giving.
Yes. So this is our structured output. Um,
Yes.
Sorry. So instead of the just judge just saying something like, yeah, it's pretty good, like in plain text.
Yeah, so basically what it's doing here, it will return, every time it returns the output, it will be in exactly the same shape. So when you see here, that is the pass and fail. So that literal type, this, what you see here, is a constraint. That means nothing else is valid. Only what we defined here, that is pass and or fail, not and, sorry, pass or fail, would be valid outputs. And the feedback or the description here, the feedback that you see here kind of explains what is the reason or rationale behind it.
Exactly. And this is very crucial because in the next step, we have a component that we will soon see called the escalation checker. And that one needs to read the status field programmatically and take action upon it.
Exactly. And if you see, like, if judge could respond however it wanted, like, oh, the research output looks very comprehensive, or it needs more work on fundamentals, oh, it's pretty solid, just as the feedback as we give, how would you write, or how would you expect the right code to kind of like detect a pass or fail? I don't think it'll keep kind of like trying to identify whether now the content builder kicks in, or how does it move on to the next stage.
Yeah. In my vision, I see a horrible regex, which will break immediately.
Yeah, you would write a regex, ship it, it would pass almost every time, works 80% of the time that we've seen, but catastrophically fails on a Friday afternoon.
Deeply specific. Yeah. I feel like that happened to you.
Yeah, I wouldn't have imagined. What if it failed, like something failed like last Friday, where we were heading into a long weekend. But yeah, I would plead the fifth. But
Yes.
here's the second interesting part of the judge. That is the agent definition itself. So we are defining the agent and it evaluates the research findings. So if you see here, it's evaluating the research findings.
I have a question here. So we see there are two parameters here below the instruction. It says disallow transfer to parent and disallow transfer to peers. What happens if you don't set those to true?
So are you talking about these ones at the bottom?
Yeah,
Okay,
exactly.
yeah. Okay, so I think by default, ADK agents can hand off the control to the other agents. So it has a feature where agents can route work intelligently. But for the judge, I don't think we are looking for intelligence. So we do not want intelligence for the judge. We want discipline. We want the judge should evaluate and return. So it just needs to evaluate and return. It doesn't need to handle what the next pass would look like, where it needs to go. So that's it. That's what we're looking for it. Nothing else. It doesn't need to like say, oh, let's redo the research, and I'll redo my research myself and like pass it back to the researcher or pass it back to the content builder, or let me ask the content builder what's their thought on the research that the researcher did. I don't think we're looking for any of those. So we just want it to give a structured output.
So we're basically taking away the agent's freedom intentionally.
Yes, and that would be nuanced at this point, because multi-agent autonomy is a dial from my point of view, and it's not a switch. So sometimes you would want full autonomous routing. The agents decide who does what, but sometimes you want more deterministic behavior, which is in this case because judge is a quality gate here. Quality gates needs to be more predictable because you don't want like random outputs coming out of it.
I love that framing. It's a dial, it's not a switch.
Yeah. So I think yeah, that's great. It just came out, but yeah. So let's just copy this, the whole schema and the agent definition go back to the console. And so if you see here in the agent.python file for the judge, we have two to do sections. One is for defining the judge feedback schema. The other one is for defining the judge agent. I copied the whole block, so I'm not doing it separately. So I just remove the whole thing from here and paste what I copied from the code lab to the judge agent. So you see now we have the schema, defined schema, we have the agent definition.
Awesome. So now, after we have our judge defined, a question to our audience. What topic would you like to test our researcher with first? Drop your suggestion in the chat. Um, let's see what people are writing here. Um, let's see. What are your ideas? What do you want to test our researcher with? If you're not going to nominate any topics, I will. So, yes. So, Priya, you can go ahead and start the testing, and I will monitor the chat to see if any good suggestion come up. I think right now our audience is a little bit sleepy or taking the time to think.
Yeah, sure. And I think we can, so we do have chat prompts here as well. I can go ahead and just use that. But I'll just first, let's
Oh,
start.
we have a few topics coming up. Oh, both are correlated. Very
Okay.
interesting from two different people. One is about future of EVs. Another one is the economics of car buying in today's economy. Everyone is searching for cars right now. Okay,
Oh, wow.
let's do the future of EVs. I like that.
So is there a specific prompt you want me to give? Just
I
create
think
a
just say
course,
future of EVs. Yeah.
future of EVs.
Let's see if it will figure out what is EVs from the
Yeah, let's see.
concept. Yeah, and thank you for your great idea. Thank you, Ray, for giving us this great topic. Yes.
So it just
Ooh.
gave us this whole thing.
Lots of text here.
Yeah, it's a lot of information. But then here you see the summary as well. Okay. The future is, oh, it's interesting. By 2040. Okay, nice.
Reimagining of the automobile. Nice. I love EVs. Yeah, great. Okay.
So we see it's a lot of text, but I'm just trying to understand like, okay, let's see if the judge would pass this.
Are you
Let's
copying all of it and giving it to the judge?
No, I think it would just take the summary. So the last summary that you see here, I think the judge basically just takes that summarized version and kind of like reviews that and performs a factual check. Yeah.
I see. I cannot overstate how useful it is to be able to test one piece at a time before combining all of these agents together.
Yeah, and this saves, I think this saves like hours of debugging. You just want to ensure like you're testing each one at a time, and I would not want to do that in production, like trying to test it in production and then kind of like trying to troubleshoot and fix it. But let's run the judge now. Okay, so we have, so we're using UV again.
It's so cool that you can just, test each of the agent independently like this with the UV.
Just gonna do a control C here. Mm,
Maybe Control C twice. Okay.
yeah. So let's ask Judge something. What was the? mm, I'm just gonna pick up some random stuff
So
from
I
the.
see people are noting in the chat that this is a lot of info, and how can we create a condensed output to prevent the cognitive surrender of the user? Well, it's not like this is not the final output. This is just the researcher given its research. The full blown course would be created later when we will do the content creation. So just wait for the next step. But
Yeah.
thank
So
you.
yeah. So basically, that the researcher would take this and then summarize version, and then like the judge would review it, and judge obviously doesn't need to like take the whole full blown input. So I'm just trying to find the right prompt that I can use from the output that we got. Do you have any recommendations? Because I think I'm scrolling through a lot of this here.
So
Um, let's do something like.
copy the summary, or do you want to add something to that?
No, I'm just gonna ask a judge. So like we have here, like finding. So
Oh,
what
topic, future
finding?
of EVs,
Yeah,
findings, the summary. Yeah.
yeah. So I'm just gonna basically just copy and change it to
Yeah.
future of EVs.
Because now we're talking with the judge, right? So we want to provide to them the research finding. Yeah.
Topic is future.
I think you have to go back and delete it.
Yeah, I keep forgetting this thing.
Yeah. Future of
Do
EVs.
future of EVs and
And the finding is the summary of that research.
yeah. So it's the summary is large. So EVs will likely be default choice. Will EVs be? I'm just giving something random. Yeah.
Oh, so you're not giving the summary of their research?
So I'm not giving the summary of the research because I just want to see whether it's like failing or.
Oh, okay. Okay.
So I'm just giving something random. Yeah.
Okay. Okay, let's see what would the judge say.
So it did fail because I gave something very random.
So what happens if you actually give the summary of what we got from the researcher?
So let's try that. Okay, can't do because it's
Of course,
yeah,
it's
shortcuts fail.
tutorial.
So the topic is future of EVs and findings. And what if I get the whole summary here? Can I copy? I copy like this. I don't want to use my shortcuts.
Yeah, and audience, if you have more ideas for
it did pass.
we can do that later. Oh, this is pass. Great job, researcher. Yeah.
The judge, not the researcher. Yeah.
No, the researcher gave a good
Good output. Yeah.
and the judge gave the good output that this is passed. Yeah, that's what I meant.
Sorry.
Yeah. Yeah, and you see that this is really a structured output, which is necessary for the next step to easily parse whether we should stop the loop or continue another round of research. And then when we reach the necessary level of quality and stop the loop, then we are ready to start building our course, right, Priya?
Yeah, I think every single time it would have the same output. And like you said, Shir, we would need to build our course. And that's where the content builder comes in, which is the next step. That is the stage 6 of our lab. So The content builder, and this is a fun one. I think it's the agent that actually produces the thing that we actually cared about. That is a more structured course. You do want modules across course. You just don't want like a blob of text which is not readable. You want like specific structure, or oh, this is lesson one, this is what I want to be focusing on, and then that's what the content builder would go give us. So let's go back for the content builder, and this is what we see here in the lab.
Yeah, so
Just
this instruction is basically a style guide, right?
yeah,
Of
so
course.
yeah, this is exactly what it is. You're just telling the agent what to do, and you're telling it how to do with like the formatting rules that we have. And consistent formatting matters, because when this output is going into a real product, you would want to ensure it's more readable and it's more understandable as well.
Yeah, so I think something interesting that someone from the chat asked about it earlier about context. So you can see here in the instructions, it references the approved research findings. So Priya, can you tell us where does that live?
So that lives in a session state. So there's a shared key value store called session.state, and all the agents in a pipeline can read from and write to. So when the researcher writes its output there under research findings, so this is basically the shared key value that we have. So the researcher writes it output under the research findings, and the content builder would read from it.
So this is basically like a shared memory between the agents.
Uh, yeah, in more like a whiteboard in a meeting room, like where one can see it and anyone can write on it.
So one thing to note about this is that the session state we're using here is only available during the same session. If you'd like to have memory that is persistent across session to personalize your agent to adapt to the user, you can use the agent platform memory bank, which is a persistent managed memory. We have a great agent factory episode about it, and we can also add the link in the comments. We added the link to the playlist so you can find it there. I think it's episode 3 or something. So Priya, let's go back to this short-term memory we're seeing here. Who manages this short-term memory or the session state? Yeah.
So we do have an orchestrator for that, but before I move on to the next step, because I didn't copy this
Mhm.
agent, this definition
Oh yeah.
to the agent, let me do that, so
Sorry,
that
I interrupted you.
otherwise otherwise we would not have the agent pipeline running. So
Yes, yes. Don't miss a step. That always happens, right?
yeah,
People miss one step and everything fails.
so we go back to the agents. Let's do, yeah. So I'm just going to close this other agent.python file that was for the judge. Go back to the content builder. Let me just double check. It was the content builder. Yes. Yeah, don't copy the agent definition for other agents into like another agent. That will mess up the whole thing.
Yes.
So we do and see here you have the definition for the content builder agent. So I'm just going to remove this and paste it here. So we have everything that we just talked about. And now we go back to the lab because we were talking about the orchestrator. So as I said, we do have an orchestrator that would do the job for us to manage the short term memory. So manage the whole flow basically. And let's go
Yeah,
back.
this is one of the key parts for those who asked about the context. Now you like we saw how the content builder is referencing what's in the context, but we actually in the multi-agent system, we actually needs to be proactive about keeping the information in that context and sharing it across all agents. So this is what we will see now in this code. So pay attention. This is important.
Yeah, and I think just going back one step. What I did was I went to the agents folder, clicked on the orchestrator, and opened the agent.python file for the orchestrator. So it is for the orchestrator itself. And because we have a starter code, so we do have an existing function here. So if you see here, let's look at the create save output callback. So this is more like a factory function. You hand it like a key, which is the research finding in this case, which we just discussed. It's kind of like managing the session state. And it will generate a custom hook that kind of like runs the exact second an agent finishes a job. So once agent A, that is the researcher, kind of finishes its job, it would kind of like trigger and it would generate a custom hook. So what it's doing under the hood is actually pretty clever. So it scrolls backward. So if you see where it's here, right here. So it scrolls backward and through the session chat history that we have to find very last real message that specific agent generated. So it will just go to the last message, in this case, like for the researcher, uh, that it generated, and it grabs that text and pins it to the global state. So the global state that we just talked about was the research findings. And remember how the judge output that we discussed was like the structured JSON. So this callback actively looks for that. So if it sees the key that is the judge feedback, let me ensure, I just don't want to like move the text around because that'll mess up the code, sorry. And the text kind of like starts with a curly brace. So the key judge feedback, and it starts with a curly brace because that's how our structured JSON output for the judge looked like. What it would do is it parses that raw string into a Python dictionary before it saves it. That means later on, when our escalation checker is looking for the information, it doesn't need to parse the messy strings. It's just checking the status. If the status is equal to pass or fail, that's just that direct.
We just help it by giving it only the pass or fail, not all
Yeah,
the extra detail
yeah.
that Judge provides, right? Yeah. So this is very cool. And thank you, our audience, for being super attentive here. And thank you, Priya, for that brilliant explanation. This was a really good deep dive to this function that keeps the output of each of the agents to the short-term memory. And you can see how it takes, this would run deterministically after every turn, right, of
Yeah,
the agents.
yeah, it would.
Awesome. Yeah. So, how do we define the agents in a way that they can actually talk to each other?
Yes. So I'm just going back to the code lab because we have the agent definition and everything there, just to ensure like everybody is getting the right set of information. So for the question you asked, like how would the agents talk to each other? We already discussed the agent to agent protocol, so I'm not like going again into the details of it because we discussed it a couple of times. But again, it will allow the agents to discover and talk to each other. But now let's define the agent's connection, or like define the connections to the orchestrator. So as I said again, so for the agents to talk to each other, we are using the A to A protocol, and that will allow each of these agents to kind of like interact with each other through the orchestrator. And all that is it's doing is, if you see, it's grabbing a URL that resolves to the agent card. So if you see here, the researcher has a URL, the judge has a URL, and the content builder has a URL. So all it's doing is taking this URL. So the agent card has it for every single agent that we have, and we're doing this for all the three agents. So let's go ahead and copy this code. So we will copy this code block from here. That is for the orchestrator agent definition. So we go back to our console, and I'm still in the orchestrator agent.python file. And now if you see here, we have the remote agents definition section, which is to define the connections to the remote agents, that is the researcher, judge, the content builder, using the remote A to A. So what I would do is just paste the snippet here.
And guys, also for this, pay close attention because this is basically how you define agents to use A2A for communication with each other. So put a pin on this. This is important.
Yeah, and as we discussed, right, this is more like the orchestrator would not care how the researcher works internally. It doesn't need to know. All it's just looking for is this URL, and it's just using remote A2A agent information and description using the agent card to kind of like interact with the other agents. So the researcher could be written in Go or any other language tomorrow. You can just change that, and the orchestrator wouldn't know. It just all it needs, as I said, is just the URL to kind of like still interact using A2A.
Oh, that these are, super cool agents. I love that. I'm looking at those important comments that you added there at the bottom. What is that?
These ones, after agent callback in HTTPX client. Okay.
Yeah, so can you tell us exactly what the after agent callback is doing? I think that is connected to context, right? Can you tell us more about it?
It is, and I think that's a critical piece of like for our loop and sequential patterns. So that is a hook that runs after the agent response. So here it takes the researcher's output and it explicitly saves that into the global session state under the key that is the research findings. If you see here, it takes the output and it's saving it under the key for research finding. And same for the judge, it would be the judge feedback. So this ensures that the judge has context it needs to evaluate the work, and the content builder can access it later. And similarly, the judge feedback that's here, the content builder basically has that judge feedback to ensure, oh, it's factually correct. Now we don't need to kind of like, or the escalation checker doesn't need to run the loop again. So it's just basically it. Yeah.
Yeah, so audience, if you're not familiar with callbacks, it's just a deterministic functions that run after every turn. So in this case, we just use it to call that function, that brilliant function that really that Priya showed before about saving the context from this agent. And this callback in this case helps us keep the state synced across all the different agents which are running separately on completely different machines. And then, Priya, I also wanted to take a look at that second parameter we have there around a create authenticated client. Is that for where the agents are actually protected behind IAMs? How does that work?
So it is, and I know we will be deploying to Cloud Run later, and we're also going to use the allow unauthenticated flag just for the demo purpose. But in production, you would obviously not use that flag, and you would absolutely log these services down. Yeah.
Yeah, we have a question from the audience about authentication method used for our client here.
So what it does is, so it basically just going a bit like one step further. So the create authenticated client function, what it would do, it would automatically handle the fetching the right Google Cloud identity tokens, so that each of these agents can securely communicate with each other. And then obviously, once we kind of like deploy to our Cloud Run, we don't have that, and we would have those in the later labs, but we are using allow unauthenticated. So all you would do is not allow unauthenticated, or do not allow an unauthenticated flag for that, and it would use these tokens that we are creating to manage the identity and access between these agents. Yeah.
Yeah, you don't want the public internet directly pinging your internal researcher agent, right? So that's why you would never do allow unauthenticated in production. You would always use authentication.
Yes, you would. And just as I said, like for the purpose of this demo, we are not showing that, and we're using allow unauthenticated, but I would never use it for production, never ever.
Yeah, and this is why we have Lab 3, securing your agent. This is with the same link we provided in the beginning, just with a -3 in the end. So if you want to take a look now, you can see that then, or you can join us in the live stream for that in July.
Yes.
Yeah, so now after we did this, let's go and explain the escalation checker, because that name made me very nervous when I first saw it. And I know it's a very critical point to end that loop, right?
I think it. I understand the nervousness, but I think it's simple, and I would say it's the simplest piece in the whole distributed multi-agent system that we have here. So let's go ahead and see what it is.
Escalation. Yeah.
Yeah. So this is the definition. Well, and all that it's doing is it just doesn't have like it's just pure Python code. It's just reading the judge feedback that you see, and it's taking that judge feedback and just checking uh, the state, and it checks the status if it's a pass or fail. If it is, then it yields an event which is like escalate true, because okay, the judge said the researchers research is pass, it's working, it's the right and factually correct, and you should be able to use that in your content builder. So what it escalation checker is doing is basically saying, oh, let's go ahead and use it, it's escalate too, so move on to the next step.
Yeah. So, audience, have you noticed what's special about this? There's no model here. And this is basically a deterministic Python code, right, Priya?
It is as I said, it's just a Python code, and what it's doing is it's just kind of like getting the output and just saying, oh, you have the feedback, it's a pass, so let's move on to the next step. Yeah, that's all it's doing.
Yeah. So, this escalation that scared me a bit isn't like a crisis escalation. It's more just, hey, let's escalate out of this loop because we actually met the quality standards for our research and we're ready to build a course.
Yeah, that's exactly what it is. So it's basically signaling the loop agent to stop, and
Great.
and
Yeah.
it's more like a break statement for the loop. So, and it couldn't be simpler than that. So you just, as you said, it's just coming out of the loop because we don't want that loop to be running.
Okay, so Priya, did we create the loop already for the researcher and the judge agent? I want to see that.
No, not yet. One second. So let me first copy this one.
Oh yeah, let's
So
copy.
let's copy this. So this is part of the orchestrator itself, because you go back to the orchestrator and you are defining the escalation checker here. So we will delete this section. I will keep the escalation checker on the top, but yeah, so we just pasted the escalation checker.
Okay, now let's add the
Let's
loop.
go back and get the loop. Yep, here it is, the research loop.
Yes, and we're using this loop agent pattern from ADK.
Yeah, so I think all it's doing is just basically, as you see here, it's taking the researcher, the judge, and the escalation checker that we have as sub agents, and it's running the researcher and the judge in the loop, and then based on the output of the escalation checker, and I think the other thing, based on the output, it's kind of like moving on to the next step in the pipeline that we have.
Yeah, and the escalation checker basically decides whether we continue back to the researcher or go out of the loop to the next um, block. Yeah.
Yeah, and you would not want an unbound loop in production, because if you see here, it has the maximum iterations 3. So you don't want to judge to be like running in loop forever, like, oh, this output is not good. Let's move on to the next one. This is not good. So if first obviously it's checking in as the status of the feedback from the judge agent, and taking that as an escalation point, but it's also using the maximum iterations as the next exit stat. Yeah.
Yeah, so if the judge keeps on failing from some reason because of bad prompt or a weird topic or some bad input, we don't want the system running out of tokens. That's why we have this max iterations, right?
Yeah, that's correct. So let me just copy it and paste it back in the orchestrator agent itself. So it goes back to the orchestrator, so where you're defining the research loop. So just paste it there.
Awesome. That's great. So after we have the loop, what is the next step? How do we pass on to the content builder?
So there's one more step. That's the final step. That will be our sequential agent pattern that we have. So we go back to the lab. This is the final pipeline, as I said. So this is the sequential agent, and what it's taking as sub agents is, here we have the research loop that already contains the other agents that we have, which is the research agent, the judge agent, and the escalation checker. So we don't have to explicitly add that. So we are using research loop as a whole, and then obviously the content builder agent that we have. So if you see here in the pipeline, you have the judge, the writer, and then the orchestrator. So that's how we are creating the sequential pattern. So let me just go ahead and copy this, and here we have, so we have the pipeline now.
Awesome. So now we have the sequential agent. That's that loop of the research and then the content builder. So the content builder returns the so the front end is only interacting with that orchestrator. Is that correct?
Yeah, that's correct. So basically, it's the orchestrator's role to kind of manage the other agents. So you're not like kind of directly interacting with, like, say, research agent, judge agent, or like content builder every single time. So it's just you have the uh, orchestrator that manages the loop and the sequential. So it manages everything for you. Yeah.
Awesome. So can we quickly test it before? I see we don't have a lot of time, but maybe we can just quickly run the test, the local test before we deploy this to Cloud Run, just to validate that all this loop and pipeline that we just defined is working.
Yeah. So let's, I think I'll just quickly show the, it's in the orchestrator. So we have the uh, run.local script, sh script, or shell script. And here, if you see in the script runs all of the agents locally, and it will export the URL for each of the agent, and that can be used by the other agent to chat with, like, previous agent or like the other agent in the whole pipeline, just as we talked about using the agent card information. So that's why we need all of these URL for.
So this is basically mimicking the cloud architecture locally on your local environment with 4 separate services that are all running locally as like, separate local processes.
That's correct. So let me just run it. I'll quickly run it. Okay, so as we're running through it, still working. But if you see here, we are getting the different URL. All agents started. You have like the researcher at 8K1, the judge at 8002, and the content builder, it's like sequential ports that they got, and like the app server or the front end is running at 8,000. So we can just see, let me see if it's done. Let me just ensure. Once it's completed, what we can do is just run that locally and see if like our entire pipeline is working correctly, and we can just give it a test prompt. And like while the test prompt is running here, we can just show quickly to deploy to Cloud Run, if that's okay.
Yeah, yeah, I think that that's a great plan. And I see some folks are asking in the chat, are these only for basic agents or can we fine tune this further? And if I understand the question correctly, definitely, this set of agents that we have here are quite basic. And as I mentioned earlier, you can take it and make the logic a lot more robust. You can take the judge and, make it actually ground all the information it gets from the researcher in real sources to make sure everything is grounded. You can have the content builder, you can add more capabilities to it, like creating a quiz or creating images or flow charts. So there are many things we can do to make this system a lot more robust. But what is important for us here in this lab is to show you the patterns and the multi agents, how they work together. But definitely we want to challenge you to go ahead and add more to it, and also share it with us afterwards. We would love to see what you've done with this. So Priya, do we have the front end?
I think it's still working, but let me just try. I'm going to just try it in parallel, but I'm going to see. So there's an option of web preview. Let's see if I can get it through there. So I'll just change the port. Just see. Yeah, it's working. Yeah.
Oh, cool. So what do we want to ask? Let's see if we have any questions from the previous round, or audience, if you want to give us some ideas for topics. Maybe, will agents replace humans? I see Vikash had this question before. Maybe we'll take that. Will agents replace humans?
Want me to ask that for the course?
Yeah, let's do a course about that. Who knows?
Okay.
What we will find.
So let's see. Will agents replace?
And while this is running, there's also another question in the chat about monitoring the agents. This is a great question. We actually have a full lab on these topics, evaluation and monitoring. That's going to be in the end of June. But we can show after we deploy it. Now, this is all running locally right now, but Priya would now deploy this to Cloud Run, and we can see how to monitor the Cloud Run service after she deployed that.
Yeah, and I think this is the first initial local run, so it might take more time. But like if you see here, you can also see as oh, it did. So it was
So
pretty quick.
quickly. Oh my God. Wow. It's that was really fast. The agent shift.
No, yeah. So you see, right, how it structured the course into different modules, like from chatbots to agent, the task versus job description, industry impact. So it's also talking about the industry impact and analysis, the human advantage, because we are asking whether agents will replace humans. So it's kind of like talking about the advantages that humans have over this. So, and then obviously practical strategy on how to agent proof your career. So there are a lot of good stuff. I just want to see what's there and how to.
I want to see how to agent proof your career.
I was going to see see that as well. Yeah. Oh yeah. Okay.
Actionable step for professionals to try.
Learning to manage a squad of agents rather than just using a tool. How the agents' most successful workers will be those who integrate agent. Yeah, I think this is true. Like integrating agentic workflows, like as you're using all of these AI dev tools, how to kind of use that to your success instead of saying, oh, that'll take over my role. So I think it's just kind of using more to uplift and kind of enable the workflow and the productivity instead of just kind of uh, shying away from it.
Yeah, I like how they highlighted the domain expertise and lifelong learning. Those are so crucial, especially when you are reviewing AI work. This is pretty. And by the way, audience, you're all in the right direction. I mean, you're here. You're learning with us how to build those agents. This is the right thing to do. So
yeah, so I think I'm not gonna do a check on you, but you can also get the agent card information for each of these agents, and we have specific curl queries here that you can run. But I'm not going to do that right now. But we moving on to the next step, because I do want to show the deployment to Cloud Run, which is the next step.
Yeah.
So the first thing that we discussed earlier is sourcing the environment variable. So before I run the researcher and the other agents and deploy to Cloud Run, I just want to ensure I'm doing that. So I'm not.
Remember our t-shirt, source.env.
Yeah, and I'm going to close this course and just exit out of it. So I'm just going to close the local test session. Oh, come on. Yes, I'm able to do that. Okay, so I'll do a clear now just so that everybody is able to see what I'm running. And then I paste. So it's just ensuring I'm in the right folder and then doing the source.env.
Yes.
It's perfect. So now we are going to deploy the researcher. So what it's doing is it's deploying the researcher, but then if you see, it's also kind of like getting the URL. So in the next step, we would get the URL for the researcher agent cart so that like the other agents are able to use it, especially the orchestrator. And if you see, we're deploying in the US West region. And as we discussed, this is the flag that we have that is allow unauthenticated. Again, this is just for the demo purpose, but you would want to change it in the production.
Yes. By default, it would not be
Yeah.
allow unauthenticated, and you would have to authenticate it to use the agent.
Yeah. So I'm just going to paste it and I'm crossing my fingers that I didn't do anything wrong.
Drum roll.
Okay.
Continue.
Yes.
Okay.
Let's let me create a new maybe I want to run it in parallel. Let's try and run it in parallel, the other ones.
Yeah, we need to have like 3 tabs, right? One we did for the researcher, then another tab for the judge, another one for the content builder, and all of them are basically the same command with the name and source directory swapped, right?
Yeah. So this one is running here, and this is the other one that I opened. But first thing first, as I said, the cloud shells. Yeah, it doesn't persist. So environment variables do not persist across the cloud shell session. So I'm just want to ensure like I have it here, did it, and now we will take the judge agent and deploy it. Let's do the judge agent as well. Hopefully it runs in parallel. Okay.
Are we in the right folder? Yes.
I think we are in the right folder. Did it? Yeah, maybe I think let's not run it in parallel. Maybe
Maybe you can try. No, you can try again. Sometimes it just feel like.
Yeah, I think let me try the researcher first.
It happened to me a few times where you just feel like.
Yeah, I think
and then
sometimes
run it again and it works. Yeah.
sometimes it takes time to get the right permissions. So let's do the researcher again. And let's see. Oh, no.
Invalid build request could not
Visual Source Cooper API. I thought we did. We did do that.
Do we need to enable the APIs again, or what do you think is the?
Okay, storage objects. Let's get run the storage object API and just ensure that it's working. What is the storage object API?
The next step would be ask Gemini.
Yeah, that's what I'm doing.
Okay.
I'm doing it in the background right now, but
yeah. But this is what we do, right? We ask Gemini. Gemini helps us debug all the time.
Yeah, so I'm just asking Gemini in the background because I have a lot of other sessions open in Gemini, so that's why I'm not sharing it. But yeah, I did ask Gemini, and I'm guessing it's like a specific because it's a completely new instance that I started with a set of projects. So it's the IAM permission. Okay, I don't have the storage object viewer role. Let's see if I can add that.
This is live debugging. Priya, you need to show us what you're doing. This is the best part for the audience.
I'm just going to try and see if I can resolve it. Let's come on. Not able to get this down. Okay, let's see if I can open it here. Okay, so let's go to IAM.
It's great that you are the IAM expert, Priya. Okay.
Okay. Okay, because I didn't accept the owner. Okay, let's see. Okay, it's a shared project that I'm using, so let me go back to the other project. So that's why, because I don't have the right roles and permissions here, but should have been fine. Let me see. Hopefully I have the other instance running. Give me 1 second.
I see a lot of great comments in the chat. Priya rocks. And people are very excited to see you debugging, Priya. They say it's really helpful for them.
Yes, so I see the owner. It's okay. So let's see why doesn't it act. I didn't see a notification. It didn't give me a notification. So I basically what I did was I created a project in another org and I shared that project with this user and gave it specific access. But I see invitation sent pending acceptance, and I'm just gonna like try and see where is that invitation because I can't see that invitation anywhere.
And we're sure this is not like an API enablement thing.
No, I think it's just like, but I'll try and give the other role as well in the meantime and just like try again and see.
Okay.
Uh, okay. Hmm. I'm just asking Gemini to help me with troubleshooting. I kind of know what the issue is, but I just want to like see what Gemini says and kind of like gives if it's able to give me like right set of steps.
We are with you, Priya.
So it's basically I don't have a bucket here, but okay. I can give the project. Let me just do is give the okay. So we go back here. So let's see if I can give the access. So I'm just trying to give the service account that's using here because it says it's not able to access the storage and all we need is just the object viewer role. So I'm just going to
Mm-hmm.
change that.
This makes a lot of sense. Yeah. So you're giving it the
The
role
right
of
role.
the storage object viewer.
Yeah. So I'm getting my right project ID. I can also use or like export the project ID into into a variable and use that variable in this command here. But like right now, I think in the interest of time, I'm just going to try this and see if it helps. Let's
Let's
see that.
see.
Okay.
Ah.
Oh, okay. Okay, so I think it because okay because I'm sharing a project and it's not like the project owner because I think it didn't accept the invite, which I don't see where the invite is yet. Let me just see. I know we'll be running into loop right now, but let me just try one more thing.
So Priya, while you're doing that, would you like me to go through some of the Q&A questions?
Yeah, let's do that. Let's do that so that we're not
You'll have
stalling.
time to debug this. Let's see. I'm looking into the questions that we have. So someone asked here, I think the name is Vital. They asked it on YouTube. They asked, can I build an agent across different cloud accounts and providers, AWS and Azure? So definitely you can. And I think what we've shown here in this multi-agent distributed system is exactly that. Because if each of your agent is defined with an A2A card, they can all communicate with each other. It doesn't matter where are they deployed, as long as you define them as an A2A agent. And then they just communicate with HTTP like we saw. So thank you for the great question. Let's see what other interesting question you have here. I see there's a great question here from LinkedIn by Kirandip Virdi. He's asking, or she's asking, can you add an instruction designer similar to Judge to this specific use case that uses instructional design principles to make the learning more sticky? That's a great idea. I love it. I love it. And I actually think you might be able to do that within the content builder. Like, we already have an agent that is in charge of building the course. Perhaps we can just give it, more instructions around how to design the course to make it more sticky. That's what I would do. But you can actually add another judge after the content builder to test the content builder output and make sure it adheres to what you're looking for. So you can have another loop pattern like we did with the researcher. I love it when we're brainstorming together like this. Okay. Let's see what other questions.
Okay, so it should work now, I think. Let me try again, because so the invite was in the email.
It's always in the email. Okay. Let's see that magic.
I just hope it runs.
Yeah, it seems like it's working now.
Yeah, it seems like it's working.
Priya, do you want, while this is building, let's talk about what Cloud Run is doing right now, like physically what's happening behind the scene when you run this deploy command.
Give me 1 second. Sorry, I'm just like.
Making sure this works.
Yeah, I'm just like. So I think I was a bit lost, but yeah. So Cloud Build, what it's doing is it's taking our source code and using build packs and to containerize it, and then we don't need any Docker files here, and that pushing that image exactly that the build files or the build packs has to the artifact registry, and then Cloud Run is pulling that and spinning up the service behind uh, using managed HTTPS endpoint. So it's just like basically zero infrastructure code for any of that, and no Docker file needed, and no Kubernetes YAML, no load balancer config. It's just all implicit.
Amazing. I love how we wrote zero infrastructure code for any of this.
Okay, so the build failed again. Let's go and see what's happening here. But it's good. Like, you can now see. So what I would do is where you can see is you can actually click on the, did it give me the logs?
Yes, it gives you the links to the logs, I think, there.
Yeah,
it's
right here. Yes.
Yeah, and you can also just open the Cloud Run
build. Yeah. So I think it's failing at the build itself. So it's just
Maybe we pasted some of the text incorrectly. Or
so let's just see what's happening here.
This is the best session where we have errors and we need to debug.
Yeah. This is the build summary execution details. I need to kind of like scroll up. Build log. No logs for this build. This could be because I need another role, that is the log explorer.
So for the next time, give all the permissions in advance.
Yeah. But let's go back and see. Let me see if I can just still open the log explorer, because it should at least show up in the log explorer. Oh, because I haven't given the right role. So okay, let's get the right load.
So Priya, do you want me to go back to the chat, to the Q&A while you do that, or?
Yes, let's do that. Yeah.
Okay,
because I
so
do want to like just ensure it's working, and we are able to troubleshoot it. Yeah.
okay, so we have another question here. When a multi from what's the name? Shyam Sundar Machi Reddy from YouTube. When a multi-agent workflow produces incorrect or inconsistent results, what debugging approaches or tooling does ADK provide to isolate which agent caused the issue? This is a great question. So actually, if you run the agent locally, you can see in the ADK web UI the trace view of the agent. So this is one way to look into that. Another thing is when you deploy it to production, you can actually add telemetry to your agent by open telemetry. And then you can look at the trace of the multiple agents and the multiple tool calls, and how that works in production. There's like this nice Gantt view of those within the Google Cloud Console. Um, we will do the next lab around evaluation, and we will also touch a little bit in monitoring and observability there. So I highly recommend to look into that. We also have a great blog post that one of our team members, Vlad, wrote about observability and monitoring. I will look for that and we'll share it in the chat in a minute. Um, okay, so let me see if I can find that. So let me see if I find that. Okay, I think I found you that blog that I was referring to that talks more about kind of continuous evaluation and monitoring. I will add that to the chat in the YouTube. So you can look into that, and maybe the TAs could also help it. Yes, Ray, Vlad rules. This is the one with the capybara. Yes, that is correct. Um, okay, let's see what other questions we have in the chat. Um, mm, mm, mm. So I have a question here. What if the agent missed something in the structure? Will the deterministic check fail and continue, or will it retry with limit? So I'm not sure what structure, like the judge will always return a structured output with the pass or fail and the details, the information. So that could not be missed because we have a structured output defined there with Pydantic. um yeah, so and if the researcher doesn't return enough information, it will be fail. um I guess, you know, if for some reason the JSON is not well defined, there will just be an error because we are trying to parse, as we've seen with the context. When we are saving the information to the context, we're actually parsing the pass or fail out. So if the JSON is not parsed correctly, there will be an error there. Okay, let's see what else. There's another question about how do you manage memory context limits before an agent's performance degrades? That's a great question. Also, so let's maybe answer that first. How do you manage memory context limit before the agent performance degrades? I think so what happens is the latest context is the one that in the end makes the most input, and in our case we're only using here the short-term memory, so it would only be the context from this session that would actually be activated. And in this session we don't have a lot, right? We have just the researcher and the judge. Those are only have maximum 3 iteration, and then, you know, the research finding are passed into the content builder. This is a sequential pattern, so there won't be a lot of we don't have any way to actually reach the context limits in this one. Um, Otherwise, I would just take under account that the agents would mainly look at the latest context as a reference. Um, Also, if agents operate in isolated directories or environments, what is the best architecture for state sharing and inter-agent decision making? So I think this is exactly what we just showed. When you have multiple agents that are collaborating and you want to have a shared context, we would usually use an orchestrator like we used here that will make sure all of the agents would save their latest context into the joint session state that the orchestrator manages, like we did here with the callback function. And let's see. And Priya, feel free to stop me when you like. If
Yeah,
you
I
want.
think I'm still troubleshooting.
Okay, okay. So next question. Are these only for basic agents? Okay, this one we already answered. Sorry. Another question here. Is the following possible with agentic systems? I provide max token usage for the project, and agentic systems are smart enough to pick and choose models to accomplish under token limit. That's a great question and actually great feature suggestion. I don't think that's an available feature at the moment, unfortunately, but we can definitely pass that feedback on to the Google DeepMind team. It's a great suggestion. Um, let's see if we have any other interesting questions here. I think I kind of completed the short list. Let's see what's happening in the chat. Let's see. How do you stress test the agent before deployment? Ray is asking here. We actually have another lab that we did last year, and I can share that, where we are running stress testing for the agent. We are using this Python package for stress testing. Let me pull that up for you. Um,
I'm just going to try a couple of more times and then we can call it a day because like just
yeah,
don't and loops. Yeah. But I
yeah.
think it should work. I think it's just the roles and permissions that I have, and we can also add it later in the description or comments, like what are the missing roles and permissions that we needed.
So I just posted in the chat the lab that we did, one of the labs we did last year, in a similar kind of run through of agents on Cloud Run. And there you can see an agent that is using Gemma as a brain. And we wrote an elasticity test that stress tests the agent before it goes to production. And because it's using Gemma on a Cloud Run GPU instance, you can actually see how the Gemma GPU instance is scaling independently from the agent, which is also deployed on Cloud Run. And you can stress test that and see how it is asking, is scaling up for more and more instances and scaling down all the way when there are no requests. And this is actually one of the most useful Cloud Run features, how it's able to scale up according to demand and scale down to zero when there are no requests. And then if you're hosting your own model on Cloud Run, you're not paying when the model is not called. So this is a great feature of Cloud Run scale to zero. Priya, what is our status?
So I'm just like basically trying to get the logs and see what's happening. It might be that I don't have access to the storage container itself, where we have the zip file that we're using for the deployment. So, or the build pack. Let me just check. Yeah.
Okay. Yes. And I think after this, we should be wrapping up.
Yeah.
And yeah, maybe just to recap, after we have all the three agents deployed in a environment with all the permissions set up, we will deploy the orchestrator agents. We will basically give the orchestrator agents the URLs for all the base agents that we just deployed, and then we will deploy it. And then after the orchestrator agents is deployed, we will grab the URL for the orchestrator and deploy the front end of the course creator, which is just calling the orchestrator. Um, and then we can test it live on Cloud Run. And I challenge you to go ahead and run through the lab yourself if you haven't already. And please share the results with us. Both Priya and myself are there on LinkedIn, on X. So please, follow us. We would love to connect with you, get your comments, get your feedback on these labs, and see what you learned, and how you're doing. Yeah.
Yeah, I think at least we've seen this. It's working in isolation locally. So the agents would be able to run. So it's just like the set permission set that I have in this new project is I need to ensure like it kind of like is able to deploy to Cloud Run. Yeah.
Awesome. So Priya, do you want to wrap it up?
Yeah, let's wrap it up because it's kind of like it'll take more time to kind of like troubleshoot this because I need to like see the build pack, what build logs and what's happening, and then kind of like troubleshoot based on that. Yeah.
Awesome. No, I think we learned a lot about troubleshooting today, in addition to building the multi-agent system. So
But I think if you see like it's a great lab and kind of like a good starting point for folks to build a distributed multi-agent system. And as you kind of like pointed out earlier, that you can tune the different agents to do specific tasks and activities, and I think the attendees also had some great ideas in how they can use it for illustration and manage like the judge output as well. So I think that's great.
yes, yes. And thank you so much, Priya, for leading us through this. And thank you, our audience, for watching. We hope this session gave you all the tools you need to build your next multi-agent systems.
And if you want to try this out yourself, like as we said, the code lab links and obviously the starter pack, everything is in the code lab itself, and then you can use the $300 credit option and free credits that's here as I've shown before to create a new project and then like use the free tier products and run this and try this code lab out as well. And then again, feel free to reach out to either Share or myself with any questions, and I will be adding, I'll share with the team for the right set of permissions that we need for the Cloud Run deployment itself for a new project, because I'm doing it in the new project. That's why it's different. And it's a lesson for me. Try it out with multiple project options when you're using a new org.
Definitely, definitely. Yeah, Priya, you can share it all with us after that in the LinkedIn or X, what are the next steps. And everyone, stay tuned for our next episode where our team will showcase how to effectively test and evaluate these systems. So I was Shir.
And thank you again for all of you for hanging out with us today, learning with us, and being such an awesome audience. Like you were so great with all of those questions and ideas. And so have a great rest of your week, and we'll see you next time on Google Cloud Live. Happy coding.
Happy coding. Bye bye, everyone.
Bye.